All right, so here for this lesson, we want to look at a vertical motion problem, and we're getting ready in our next lesson to look back at kinematics or rectilinear motion again, but in this case, dealing with integrals. And as you can see here, we have a ball is being thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. Okay? And what we actually, I know that you have learned formulas to be able to write a function for this in the past, but I want to see how these formulas are actually derived. Okay? And this is a problem that you could do a little more directly just using one of those formulas, but let's suppose that we don't know what the formula is. Okay? What we are actually given here are two initial conditions. Okay? The initial height, which remember we used S, they ask us for S as our height. So S of t is what we're looking for, but here what we're told is that we have an initial height of 80 feet. So that's S when?
0.
At t equals 0. So S of 0 equals 80 feet. Okay? We're also told we have an initial velocity. Okay? Now, initial again means when t equals 0. So they're saying v of 0 is a positive 64. Okay? Now notice it said it's thrown upward. So we're going to assume it's thrown straight up. That entire 64 is going straight up. So we're not going to deal with vectors at this point. Okay? Now, it says here that the acceleration is a negative 32 feet per second, because that's gravity in terms of feet per second squared. Okay? So, look at what we're given. We are told acceleration at a given time is a negative 32. That's constant. All right? Now, think back what we learned before. How did acceleration relate to velocity? It's the derivative. That's v prime of t. So question, how do we find v of t? We take the antiderivative, or the integral. Okay? So this is going to be the integral with respect to t of that acceleration. Okay? So, we have now, what's the integral of negative 32?
Negative 32x plus c.
Yeah, although we'll use t just to stay consistent, but yeah. Okay, the integral of negative 32 with respect to t is going to be a negative 32 t plus c. Okay, so that is the velocity. Now, if I want the actual position function, I can't leave that plus c in there, can I? All right, I need to go ahead and figure out what the c would equal. All right, well, what is the c going to equal? The initial velocity. Okay, so here's where finding the particular solution is important. Okay, now this one is a little more obvious, but I'll show you the mechanics of doing it, because it's not always going to be the fact that c is v of 0. Okay? Alright, so I have my 64 equals negative 32 times 0 plus c, so c does equal 64 in this case. And that gives me my final velocity function, which is a negative 32t plus 64. Okay? So there we go. But we're not done, because we didn't want the velocity function, we wanted the position function. Okay? How does velocity relate to position? It's the derivative, okay? This is s prime of t. So how are we going to find s of t? Take the antiderivative. Alright, s of t equals the integral with respect to t of the velocity. Okay? So we have the integral with respect to t of a negative 32t plus 64.
Bless you.
Thank you.
So what is s of t?
Negative 16 t squared
Negative 16t squared
plus 64 t
plus 64t
plus c.
plus c. Okay?
What is CDE?
So remember your rules for taking the integral. It's you add 1 to the power, so it's t squared, and then you divide by the new exponent. Okay? The integral of the constant, we could think of it as t to the 0, so if I add 1, it's t to the first, divided by 1 is just t. And then we have this plus c. Okay? So, once again, we're going to plug in the s of 0 is 80 because we want a particular solution. Okay? So that was a negative 16, so negative 16 times 0 squared plus 64 times 0 plus c. C equals 80. So we plug that in, and we get s of t equal to a negative 16t squared plus 64t plus 80. And that, guys, is where we get our formula that you may have learned in the past, where you have 1/2 at squared plus v sub naught t plus, might have x sub naught or plus, in this case, s sub naught. Okay? The acceleration here is the acceleration of gravity, which is negative 32. Okay, so that's where we get the negative 16. All right, that's where that formula came from. Okay? So when you use it in physics next time, you can appreciate it a little more. Okay? So now, where does it hit the ground? Well, we know it was launching off at an initial height of 80. Okay? If we want it when it hits the ground, we're just going to set s of t equal to 0. Okay. All right, so s of t equals 0. So that's the negative 16t squared plus 64t plus 80. I'm going to go ahead and divide everything by a negative 16, because that'll still be a 0. That'll be t squared minus 4t minus 5. And then I can factor that pretty easily. T minus 5 t plus 1. So that actually shows me that 1, 2, 3, 4, 5. If I were to track this motion where this is s and this is t, okay, I'd have this kind of parabola looking thing, and it would be crossing right here at 80. Okay?
So it like bounce back?
Well, no, the idea, this is just a model, right? So realistically speaking, the motion started here at 80, it went up and then fell down and hit the ground after 5 seconds.
So do you need a graph the negative one or no?
You don't have to.
Okay.
If we figured out how fast it was going when it hit the ground, we could also say, okay, well, if I shot it up at the same angle at however far, from the ground at that velocity, it would make it up to 80 feet in 1 second. You could kind of use the symmetry in that way. But, okay. That's the basic idea. Again, these are concepts we've dealt with in the past. Position, velocity, acceleration. Now we're just moving backwards through them. Okay? But this is where that particular solution comes in handy, and we're able to use the antiderivative to find previous things. We're not only going to be dealing with this, but this is a good one to start with. This rectilinear motion is great to start with because it's a context we're a little more familiar with. The danger of starting here is that people start to make the assumption that C will always be the V of 0 or S of 0, okay? It doesn't always work out that way when we're not dealing with polynomial functions, okay? So just be careful with those, okay?